every session. The initial steps of writing and storing source code in Java. So we store source code and how the source code will convert the intermediate called as bytecode and link to executable. So all those things we are going to see. The first step is here. Once you write the source code, so we will write the source code using the text editor called Notepad or any IDE. So whatever program type in Notepad, so it will be stored in the hard disk. That is the first part. So all the data what we are type, all the program what we type in Notepad will be stored in the secondary memory. Once you save the file, it stored the file in the secondary memory like hard disk or SSD. This is where your size until need to access or complete. And the next step, once you store your file in the secondary memory, the translator converts the source code to executable code in two phases. One is compiler phase, another one is Java virtual machine. So in compiler phase, it converts the source code to bytecode, and in the JVM phase, it converts the bytecode to executable. And following that, we will see the compilation phase. So this is the entire flow of how the program is stored and how it is converted to class code, and finally how it is converted to executable. So here the compiler. So whatever program we type, for example, if I am typing the program under the name demo program.java, so the compiler reads first first step is the compiler reads the demo program from the secondary memory using Java C command. So the file is formed, it stores the file in primary. Otherwise, it throws the error file not found. So after storing the file in primary memory, the compiler checks the syntax and semantics of the Java file. The syntax and semantics are correct, then it generates bytecode. If there is an error, then it shows a compilation error, and this phase is called as compilation phase. And the next step is bytecode. This you all know that bytecode is generated by the compiler and it is called as platform independent. So once the bytecode is generated, we can run the bytecode anywhere, any operating system. So we call that as platform independent understandable code. And the next phase is execution phase. In execution phase, we call this phases here the JVM process. So Java Virtual Machine process. So the second translator JVM, it converts the bytecode to executable code and it is suitable for the operating system, any operating system. So we will check how it works. So first we will load the file. So that is the first step. Every time we have to load the file. So initially the file is in secondary memory. First we load the file in secondary memory. Once the file is found, then it will be transferred to the primary memory. Now the Java command, it checks whether the program demo program class file is formed. So if the class file is formed, then it loads the class file into primary memory. So once the class file is loaded, then we can execute that. So that is the idea. If the class file is not found, means the same procedure, it will throw the error that is class file not found. So that every time JVM converts the bytecode into executable code and it is suitable for any operating system. So the first step is from secondary memory, the file will be loaded to primary memory. From primary memory, the file will be executed. So this is the workflow, how it works, how the Java programming language works. So and we also call Java as platform independent because here we are generating. See, in all other languages, the source code will be converted to executable, but that is not the case in Java because here we have the intermediate called as bytecode. This bytecode, it can be run in any operating system, Windows operating system, Linux, and Mac. So this JVM, it converts. For example, if you are using Linux, means JVM converts the bytecode Linux understandable executable. And if you are using Windows means JVM converts bytecode to Windows understandable executable. Similarly for Mac OS. So Java is called as platform independent language because of its write once run anywhere capability. This means that once Java code is compiled into Bytecode, it can run on any device or operating system that has virtual machine installed without needing to be recompiled. So this portability is one of Java's strength and it making it widely used in various applications across different platforms. So when a user runs a Java application, so in this slide we are going to see Java runtime. So when a user runs a Java application, the JRE is responsible for providing the environment in which the application can execute. So the JVM can execute, application can execute. JVM within the JRE interprets the application's bytecode and executes on the host machine. So together, so right now, first you have to, for example, all the time once you start working, you come to know JDK kit. So inside this JDK kit, you have JVM libraries and developers. And this Java runtime environment, it composed of JVM and libraries. So together, we call this as Java runtime environment. This Java runtime environment and JDK are binded. So, so once you are executing any Java programming language, means it is necessary that you have to install Java runtime. But inside Java runtime, you inside the JDK kit, you have this Java runtime environment and the support files. Thank you.